welcome to my channel Summary S. In the last few videos, we talked about the concept of signal and we also covered two types of signal, that is continuous time signal and even and odd signal. In today's video, we will be talking about periodic and non-periodic signals. So, periodic signals are the signals which repeat themselves after a particular instant of time. So, mathematically, we can say that a signal xt is said to be periodic if xt is equal to x of t plus t. So, xt is a continuous time signal which we have already covered in the previous classes, the previous videos. So, xt is a continuous time signal and it is said to be periodic if xt is equal to x of t plus t, or we can also write it t plus mt. So, what does this mean is that this is a sinusoidal signal, and as you can see that this sinusoidal signal repeats itself after a particular instant of time. And what is that time? So, if the signal starts at this point, then we can say that this is one cycle, and exactly at this point, which I can write as t, the signal repeats again. The signal repeats again. So, if I want to draw some more cycles, so I can draw it like this. So, it can repeat itself continuously like this. So, if this is t, again the second cycle completes here. So, this is 2t, similarly this is 3t, and so on. So, the signal which repeats itself after a particular instant of time is called periodic signal. Now, what is that instant of time? Here you can see that we are writing it as t. A signal xt is repeating itself again after a time interval t, and similarly we can write it as 2t, 3t or 4t. So, in general we can also write x of t plus mt, where m is constant. So, m here can be either 1, 2, 3. So, if it is 1, it will be t, or 2t, or 3t, and so on. So, signal repeats itself after a particular instant of time. Such a signal is called periodic signal, and the smallest time after which signal repeats itself, that is capital T, is called fundamental period. This is called fundamental period. It is the smallest time after which signal repeats itself. So, I hope you understood that what is the meaning of this expression, that is a signal repeats itself after a time t, and or you can say multiples of t, 2t, 3t, 4t. Similarly, if we talk about discrete signals, the concept is exactly same. A discrete signal xn, so if xn is a discrete signal or sequence, then it repeats itself after a particular instant of time, that is x of n is equal to x of n plus capital N. Here the period is denoted by capital N. Here the period is denoted by capital T. T is the fundamental period. So, the period is denoted by capital T here, and here the period is denoted by capital N here. Obviously, if you can recall, in continuous time signals, T can take any value, capital T can take any value, but in discrete sequences, the value of small n as well as capital N will always be integer. If you have any confusion in this concept, you can revisit my video on continuous time and discrete time signals. So, the value of capital N or small n is always an integer, while the value of T or capital T, small t or capital T will always, it can take any value. Let us take example for periodic discrete time sequence also. So for example, if there is a sequence which is 1 here, so here suppose the amplitude is 1, then we have -1, again we have 1, again -1, again 1, and so on. So from this it is clearly visible that if the signal starts at n equal to 0, then it again, so this will be n equal to 1, this will be n equal to 2, this will be n equal to 3, and this will be n equal to 4, and so on. So here the capital N will be 2. Why? Because the signal started at n equal to 0 and it again repeats itself at n equal to 2, then n equal to 4, and similarly then at n equal to 6, and so on. And the same graph will also continue in the negative side, means at -1, then at 1, then at -1, and so on. So this expression therefore can also be written as xn plus mn, where both m and n, m is also an integer and capital N is obviously an integer because it is discrete time signal. So I hope you understood the concept of periodic and non-periodic signals. This is the formula for periodicity. This is the formula for periodicity. These two are the equations for periodicity. So this is for continuous time signal and this is for discrete time signals. And any signal which does not satisfy this criteria is called as non-periodic signal. Any signal which does not satisfies this criteria is called a non-periodic signal. Periodic signals always repeat themselves after a particular instant of time. So I end this video here. In the next video, we will be taking some examples of periodic and non-periodic signals. So the periodic and non-periodic signals will be covered in different parts in the different videos. So this video is part 1 of periodic and non-periodic signals. To learn further, you can visit the next video, which will be part 2 of periodic and non-periodic signals. So for that, I request you to subscribe my channel so that whenever a new video is uploaded, you can get information about it. Thank you very much. Thank you for watching this video.